Hey guys, welcome back. So today we're going to be going over ways to derive a sum of two functions here. So in the problem we're being asked to take the derivative with respect to x of the constant a being multiplied in by the sine b of x, or bx, and then we're adding it to another constant c. When I see something like this, I can see I've got a binomial almost, where I've got something being added into another something. So what I can do is I can then distribute the label, even though we're not multiplying it, we're then taking the derivative of both of these terms here. So I can rewrite this as the derivative with respect to x of a times sine bx. Make that a square bracket to really distinguish what we're doing here. And then I'm going to be adding this because this is going to carry over as well to the derivative with respect to x of c. And I look here, okay, I've got a function here, which is great. I have a composite function, so I'm going to be using the chain rule, which is what we're going to go over in a sec. But then here, I just have a constant. So when I take the derivative of a constant, we get a nice goose egg 0, so that then goes away. So we then go on. Yes, Jenna, go ahead.
Why is the derivative of a constant 0?
So that's a great question. So when we talk about the derivative of a function, we usually are trying to find the slope. So over here, we have a graph, and if I'm plotting c as a function of x, this is my line c here, and what the slope of this line is equal to 0 because it's a horizontal line. You're normally, when you find the slope, you're going to be doing rise over run. In this case, you're not going up at all, so you're just staying on that same line. So what the slope is actually telling us is we have the derivative with respect to x of whatever function we're taking the derivative of there, which gives us that slope. Cool, awesome. So when I can rewrite this now. So I now have the derivative with respect to x of a sine of bx. And like we said, we're going to be using the chain rule here because we have a composite function where we have the sine as a function, and then we have the bx as another function. And so what the chain rule is telling us is that when I'm taking the derivative with respect to x of a function with inside another function, then I'm going to be substituting in for this term gx, and I'm going to let that equal my u there. So when I take the derivative, I now have the derivative with respect to u of f of u multiplied by the derivative of u with respect to x. And then we get from here the derivative with respect to u, f of u, multiplied by, when we substitute in the g of x, the derivative with respect to x of g of x. So we're going to apply this same thing over here now. And I notice here that my composite function has a constant out in front, and there's no x term being multiplied by the a. So what this tells me is I can take this here and pull it outside of the derivation. So I can then rewrite this as a, the derivative with respect to x of the composite function sine bx. And so what we're going to do is the same thing we did over here, is what we let the u equal my inner function g of x here, I'm going to let my u equal my bx term here. And so when we do the chain rule, the A is just along for the ride. It's like when my friend Lily and I go on a road trip. I'm the one driving, she's just there sleeping and just relaxing. The A is Lily in this case. So when I take the derivative of the first function here, we have the derivative with respect to u, sine of u, and then being multiplied by the derivative of u with respect to x. And then for this one here, we're going to plug in the bx value. So we're going to carry over the a still, the derivative with respect to u of sine of u, and then multiply that by the derivative with respect to x of b of x. And so when we take the derivative of these, I'm then going to get here, I get a, the derivative of a sine is cosine, and then I'm multiplying that by the derivative of bx with respect to x, and that's just going to give me a b here. And once I have a simplified form, I'm then going to plug my u back into the equation here. And because order of operations is when I'm multiplying, it doesn't matter the order. And I'm going to have my AB being multiplied to each other, multiplied again by the cosine of my BX term inside here as my final answer. Awesome. Thank you guys so much for watching, and I'll see you in the next video.